triangle exterior angle theorem stated that the measure of angle 1 plus the measure of angle 2 has to equal the measure of angle 3. The two remote interior angles, when you add them, it equals the exterior angle. The corollary reads that basically the measure of the angles, so 40 plus 30, has to be less than z. So the measure of angle 30 plus their measure of angle 40 has to be less than z. Less than angle z, not equals. So that kind of follows into side length relationships. So to figure out the side that is the shortest, it is the side opposite the smallest angle. So if I write these angles or the sides in order from least to greatest as far as their shortest to longest distance, the shortest one would be the segment BC. Then the next smallest angle is angle C, so opposite of C is AB. So the next shortest side is segment AB. And the longest side is opposite the longest angle, so that would be side AC. So you look at the angles, go right from least to greatest or greatest to least, and then you have to write the sides that are opposite of the angle. You can do the same thing with side lengths, go backwards. If you know the shortest side is opposite the smallest angle. So angle C is the least, and then 11 is between. So the side that's opposite 11 is B, the angle that's opposite is angle B. And then the next one is the longest side is 14, so the angle opposite of that is angle A. The triangle inequality theorem states that the sum of any lengths of any two sides of a triangle is greater than the lengths of the third side. So just in this picture, there's no way that you could have a side with 10 and then 4 and 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you had 4 toothpicks right here and then you had 5 toothpicks, there's no way that you could form a triangle with 10 toothpicks, because this would just be, it wouldn't close. There's no way it would close. So if I look at this triangle, the different options that this side could be is it couldn't be 4, because 7 plus 4 is less than 12. It wouldn't close. It couldn't be 5, because 7 plus 5 equals 12. So it needs to be more than 5. Okay, then let's think about what, so it can be 5, 6, 7, 8, 9. Let's try 10. So 7 plus 10 is still more than 12. So that works. And then 11, 12. Basically, how high can we go until you can't have a triangle? 15, 16, 17, 18. Let's see what happens with 19. So if you have this side is 19, now you have to look at these two being the shorter sides. So if you had 7 and 12 is not greater than 19. So that wouldn't work. 20 wouldn't work the same way. So it's more than 12, less than 19. So what you do basically is if you have these two lengths, you subtract these two lengths, you find the difference and get 5. Then you add the two lengths and get 19. And the third side has to be between the two. It can't be 5, it can't be 19, it has to be in between. So that's how you write your inequality. Alright, these down here. Can the triangle have side lengths with the given lengths? So what you do is you look for the two shortest side lengths, add them, and they need to be greater than the third side. 4. So is 2 plus 2 greater than 4? Is 4 greater than 4? Nope. And that's how I show my work. So you find the two shortest sides. 10 plus 5. Is 10 plus 5 greater than 14? Is 15 greater than 14? Yes, so you can have it. And then you find the two shortest sides. 8 plus 10. Is 8 plus 10 greater than 19? Is 18 greater than 19? No, so it can't make a triangle. And then down here, in triangle ABC, so I'll draw A, B, C. AB is 12, BC is 14. Describe the possible lengths of the third side. Well, this is kind of like the example I did where you had that 7 and 12. So what you do is you subtract 14 minus 12 and you get 2. And you add 14 plus 12 and you get 26. So that means that x has to be in between 2 and 26. Same thing in the next one, triangle XYZ. XY is equal to 10, YZ is equal to 2. Describe the possible lengths of the third side. So I subtract 10 minus 2 and I get 8. And I add 10 plus 2 and I get 12. So that means that x has to be between 8 and 12.